Why is ice slippery? You probably understand it as being pressure melting, and that's actually wrong. We thought that for 200 years, and only recently has science figured out that that's actually incorrect because the pressure a human standing on ice exerts can only change the melting point of ice by 0.1 degrees Celsius, which is not enough to melt a surface layer, especially at really cold temperatures like negative 30 degrees Celsius. And so something else is going on here. So what's actually happening is ice, just naturally, has something called a quasi-liquid layer on the top of it. Because of the way that ice freezes, when water molecules connect in freezing, they create a crystal structure, but at the surface, you have a layer on the ice that's not quite liquid and not quite solid. It's called a quasi-liquid layer that is kind of, you can think of it as like a super molecule thin layer of slush that's sitting on top of the ice. And so when you step on it, you actually slip on that slushy layer, that quasi-liquid layer. And it gets worse when you wear something like rubber or leather shoes, because rubber and leather have dipole molecules in them. Now what that means is that leather and rubber have molecules that are slightly positive and slightly negative on two sides, and water molecules are polar, which means they're positive and negative. And so when your positive and negative molecules interact with the positive and negative molecules of the water, they disrupt that quasi-liquid layer even more, making it bigger, making it even more slippery. And so that's why ice is slippery. It has nothing to do with pressure melting. Pressure melting is almost negligible. Anyways, I hope you learned something, stay curious, and go Scepters.